So now that we've talked about the individual shape and structure of an atom, we're going to start to look at compounds and molecules. A molecule is going to be two or more atoms that are bound together. A compound, if you hear that term, is going to be a molecule that contains at least two different elements. So all compounds are molecules, not all molecules are compounds. It's kind of like how all squares are rectangles, not all rectangles are squares. In biology, we tend to just use the term molecule because it's all-encompassing. I'm not going to be particular in this course. You'll see both compounds and molecules used a lot. I'm not going to be particular or fussy if you use one term and not the other. But just for an example of compounds and molecules, what we have below is going to be the molecular formula for glucose. So one molecule of glucose is going to contain 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. So the molecular formula for glucose is going to be C6H12O6. Now, I'm not expecting you to memorize this, however, you probably will. We are going to spend a lot of time with glucose over the course of this semester. You are going to see that formula a lot, C6H12O6. Oops, computer's frozen a bit. And as we've mentioned before, electrons possess energy, as do the bonds in between atoms. Organisms are going to be directly dependent on chemical bond energy to help maintain their organization. And as we'll learn later this semester, organisms are going to routinely break down this particular molecule, this glucose molecule, in order to obtain energy. The energy is going to be obtained when the electrons change in their relationship, or shift or change their relationship from one another. So we're going to start to look at specifically that chemical bonding process. So chemical bonding is just the bond that exists between atoms in molecules. These particular bonds are going to contain high amounts of energy depending on how those bonds are formed. These are caused by the interactions between electrons in the outermost shell. Take a moment here, shout out, what do we call the electrons that are found in the outermost shell, energy shell, of a atom? And what do we call the outermost energy shell? So the process of bond formation is going to be called a chemical reaction. And that's all chemical reactions are. Just the formation of bonds and the destroying of bonds is going to be the making and breaking of bonds. We're going to spend a little bit of time looking at different types of bonds, starting off with an ionic bond. An ion is going to be an atom that has either lost or gained an electron, and this will create either a positive or a negative charge in the atom, so thus all ions are going to be charged atoms. So what happens is we're going to have a positively charged atom and a negatively charged atom, and sort of like how two magnets can have opposite charges, opposites are going to attract. A positively charged atom is going to have an affinity for a negatively charged atom. So we're going to start off by looking at this example of sodium chloride. What we're going to see here is when we look at sodium chloride, the chemical formula for sodium, the chemical formula, or not the chemical formula, the atomic number for sodium is going to be, we're going to back up to our periodic table. Here is our sodium right over here on the periodic table, is going to be 11. And our atomic number for chlorine is going to be 17. So we're going to start off by taking a look at our sodium ion. And I would like you to follow along and draw an atom of sodium as you work through this to help kind of understand this process. But if we were to draw an atom of sodium, we have 11 protons. We have, we have 11 protons. We have an atomic mass of 23, if we round that to the nearest whole number. Which means that we have a grand total of 11 protons and 12 neutrons. If we have an electrically neutral atom, how many electrons do we have in our atom of sodium? Very good, 11. If we have 11 protons, we must have 11 electrons in order to properly balance that out. So if we were to draw our molecule of sodium, we would start off by drawing our protons and neutrons right here in the nucleus, and then we would start to fill in our electrons in the outermost shells. Now sodium has 11 electrons. We're going to start off by filling our first energy shell. If you remember, our first energy shell can only hold up to 2 electrons. So we're going to put 2 electrons in that first energy shell, and then how many electrons do we have left? 9. 11 minus 2 is going to be 9. We have 9 electrons remaining. So our next energy shell can hold up to 8 electrons. So we're going to put 1, 2, 3, 4, 5, 6, 7, 8 electrons in our second energy shell. How many electrons do we have remaining? We started with 11, we put 2 in the first shell, 8 in the second shell, we have 1 electron remaining. Now that's going to be out here in its outermost shell, its valence shell. We have 1 valence electron. Now, does anybody remember from the octet rule, what do we know about an atom that only has 1 electron in its outermost shell? It's not going to be very happy. It's not going to be a very stable electron. What happens is we want to have, or all atoms want to have, a complete octet in their outermost shell. Now, what do we need to do in order to gain a complete octet? We need to either get rid of 1 electron, or we need to take on 7 more electrons added to our sodium atom. So we either need to pick up 7 more, or we can get rid of 1. And that's what our sodium needs to do in order to have only 8 electrons in its outermost energy shell. So we're going to be looking for somebody that either needs 1 electron or has 7 electrons to spare. So we're going to go over to chlorine, and we're going to take a moment to look at this chlorine atom. Chlorine, if you look at the periodic table, backing up just a moment to the periodic table, chlorine has an atomic number of 17, and we have an atomic mass of 35. So if we have an atomic number of 17, that must mean that we have 17 protons, and we must have 18 neutrons. 35 minus 17 is 18. If we have 17 protons, how many electrons do we have? Very good. If we have an electrically neutral atom, we are going to have, or we're going to need 17 electrons to balance out those 17 protons. So we're going to start off by drawing our atom of chlorine. Chlorine has 17 electrons. How many electrons can we put in that very first energy shell? 1, 2. Remember, that first energy shell can only take up to 2 electrons. Then we're going to fill up our next energy shell. We have 1, 2, 3, 4, 5, 6, 7, 8 electrons in the next energy shell. That means we have how many electrons remaining? We started with 17. We put 2 in the first shell, 10 in the second shell, which means we have 7 electrons in our outermost shell, or our valence shell. 1, 2, 3, 4, 5, 6, 7 electrons in our outermost shell. How many electrons does chlorine want in its outermost shell? Very good. Chlorine, like everybody else, wants 8 electrons in its outermost shell. So he is either going to have to give up 7 electrons or pick up 1 additional electron. He's going to either have to donate 7 or pick up 1 in order to have a happy valence shell that has completed its octet. So here's what's going to happen. Sodium has 1 extra electron that he wants to get rid of. Chlorine is missing 1 extra electron that he would like to pick up. So sodium's going to be like, hey, I don't want this. Do you want it? And he's going to donate. He's actually going to give up an electron to chlorine. So when we give our electron over to chlorine, so we're going to give it up over to chlorine, what happens is we actually create ions. Because here's the thing about sodium. Sodium, as we said, has 11 protons, remember? Sodium has 11 protons, or 11 positive charges. And he started off with 11 electrons, or 11 negative charges. Here's the thing though, he just gave up one of his negative charges. So now the overall charge on sodium has changed. He has 11 positive charges and only 10 negative charges. So the overall charge on sodium is now going to be positive. He has a +1 charge. Chlorine, on the other hand, started off with 17 electrons, and he now has 18 electrons. So he has 17 protons, or 17 positive charges, but he now has 18 negative charges, which means that chlorine now has a negative charge. So we've given up, or we've donated an electron from sodium to chlorine. When we get rid of that electron, sodium becomes positively charged and chlorine becomes negatively charged. Now here's the funny thing. Their relationship isn't over yet. Sodium gave up that electron, but now that we have a positive charge here and a negative charge here, the two of these are going to be attracted to one another because of those opposite charges. Opposites attract. So now we have an attraction, or a mutual attraction, between the positive charge with sodium and the negative charge with chlorine. So just to review, an ionic bond is formed between two ions. An ion is going to be an atom that has either lost or gained an extra electron. An ionic bond is going to form when those electrons are transferred from one atom to another atom, and the oppositely charged ions are now attracted to each other because of their opposite charges. And we're going to pause right there for ionic bonding. Make sure that you go over ionic bonding and you do understand it. There will be questions about it in your homework and on the test, so please review ionic bonding before moving on to our next video of covalent bonding.